So this is the first lecture on the topic convex functions under the subject Maya theory, and the notes have been taken from the book Real Analysis written by H.L. Chordal, and it is taken from the fourth edition of the book. So we will talk about firstly the definition of the convex functions. So what is the definition here? You can see we have written a real valued function phi on open interval AB. That means the phi function is defined on the open interval is said to be convex provided for each pair of the points x1, x2 belonging to AB and lambda which lies between 0 and 1, we have this condition phi of lambda x1 plus 1 minus lambda x2 less than or equal to lambda phi x1 plus 1 minus lambda phi x2. So what is the meaning of this condition? Let us talk about this in detail. So firstly, I will make it clear to you what is the meaning of this equation firstly. So for this, let us calculate. We have x1 and x2 lying between AB belongs to open interval AB. That means x1 lies between A and B and x2 lies between A and B. You can see here we have multiplied x1 by lambda. So in this equation, multiplying all the sides by lambda, and obviously lambda is positive. So we can do it very clearly. And also because lambda lies between 0 and 1, so 1 minus lambda obviously is also a non-negative quantity because lambda is less than 1, so 1 minus lambda is non-negative quantity. And for x2, we need to be multiplied by 1 minus lambda. So multiplying by 1 minus lambda on all the sides. And now simply adding these two values because we need lambda x1 plus 1 minus lambda x2. We need the addition of these two values. So adding these two inequalities, we will get these things. And you can see on simplifying it, you will simply get A. And on simplifying this, you will simply get B. And that means the value which we have taken the input also lies between A and B. So obviously, if we let x is equals to lambda x1 plus 1 minus lambda x2, so that means your x belongs to AB. So this value represents, so what does this value represents? This value represents that if x1 and x2 are any two inputs, if x1 and x2 are any two inputs, this is our xy plane simply. So this is the point x1, this is the point x2. So the point will be x1 phi of x1, and this point will be x2 phi of x2. So that means that your x represents every point on this straight line. So every point on this straight line, that means we are taking the input every point on the straight line, joining the points with x coordinates x1 and x2. So this is the simple meaning of this input. Now, what is the meaning of this condition, which is making our function a convex? Phi of lambda x1 1 minus lambda x2 is less than or equal to lambda phi x1 plus 1 minus lambda phi x2. So let us discuss this geometrically, then I will make it more clear to you. So for graphical representation, for geometrical property of the convex function, look at the following figure drawn in the R square plane. Observe that for x1, x2 belonging to AB, each point x in x1, x2 may be expressed like this. And you can see, you can also calculate the value of lambda from this equation also. Your lambda will be x2 minus x divided by x2 minus x1. So now talk about that condition graphically. So these are the 2 points, as I have told you earlier. This is the point with the abscissa x1, and this is the point with abscissa x1, and this is the point with abscissa x2. And obviously, their ordinate has been represented here, phi of x1, and its ordinate is represented here, phi of x2. So this is the straight line joining the points x1 and x2. And as I have told you already, obviously this value lambda x1 plus 1 minus lambda x2, this value will obviously lie between our x1 and x2. So this is the point on the straight line for this. This is the abscissa. the abscissa of this point is x, and whatever be the value of the ordinate. And this is the point. This is the point whose abscissa is x and its ordinate is phi of x. Obviously, because this is the curve phi. The blue curve drawn is the curve phi. So if this is the point phi of x, that means this is the value uh, in front of this, say here, say here. This is your phi of x. That means this is the value phi of lambda x1, 1 minus lambda x2. The left-hand side of the inequality of the convex function. So what we have talked about in the definition of the convex function, this value is less than or equal to lambda phi x1 plus 1 minus lambda phi x2. So that means comparison of these two ordinates. Comparison of these two ordinates. So obviously this height is this ordinate is lambda phi x1, 1 minus lambda phi x2. This ordinate. And this value and this ordinate is phi of x, the left hand side. So we are saying in the definition of convex function, this ordinate is less than this ordinate is less than this ordinate. Obviously, you are saying it from the figure. So why it is called a convex function? You can see the curve is of the shape convex downwards. So that's why this function is called a convex function. Because otherwise, if you draw, then obviously this point will lie here. So it will not be less than. So if you want to make this ordinate less than, if you want to make this ordinate less than this ordinate, then obviously you need the shape of the curve should be like this. So that's why the function is known to be a convex function. Hope you have all have understand it. Now, if we look the graph of phi, the convexity inequality can be formulated by saying that each point on the chord between x1 phi x1 and x2 phi x2 is above the graph of phi. So as I have told you, this is the point on the chord and this is the point on the graph phi. So this point is always above this point. So this is the geometrical meaning of the convex function. Now, hope you all have understood the definition of the convex function. So this is the definition. You can see phi of lambda x1 plus 1 minus lambda x2 is less than or equal to lambda phi x1, 1 minus lambda phi of x2. So now let us move further. The chordal slope lemma. This is a very important lemma of in the topic convex functions. So what does this mean? I will also discuss about its name, chordal slope lemma, when I will talk about the geometrical meaning of this lemma also. So first, let us see what is its statement. If phi is a convex function on open interval AB, and you have 3 points like this, x1, x2, and your x lies between x1 and x2 in AB, then we have to prove this inequality. Actually, you can see this is the slope of the points of the straight line joining these 2 points. You can see as in the earlier classes in the +2 standard, maybe or 10+1 standard, we have calculated the slope with the formula y2 minus y1 upon x2 minus x1. So this is the same thing. This is your y2. This is your y1, you may say. This is your y2. This is your x1 and this is your x2. So simply you can see this is y2 minus y1 upon x2 minus x2. Similarly, this value is the slope of the points of the line joining x1 phi x1, x2 phi of x2. And similarly, this is the slope joining the points x phi x and x2 phi x2. So that means we are just comparing the slopes here. So that's why the lemma is also called a chordal slope. So actually we are measuring the slopes of the chord and making their inequality. So let us see how we have to prove it. Since for 2 points x1 less than x2 in AB, each point x in AB may be expressed as x equal to lambda x1, 1 minus lambda x2, as we have discussed this point in the definition of the convex function, and you can calculate the value of lambda from here also. How you can calculate it? You can simply open the bracket minus lambda x2 x and simply uh, take these two values of lambda on the right hand side, lambda x2, and take lambda common and switch the value of x on this side, and simply you can get this value of the lambda by dividing x2 minus x1 here, right? So in this way you can calculate the value of the lambda. So as phi is given to the convex function, so this is the condition of the convex function as we have discussed in the definition of the convex function. The above inequality may be written as, now what I have done here, I have simply write this value as x, okay, and substituted the value of lambda x2 minus x upon x2 minus x1, and similarly here. So in this value, I have just taken the LCM. So with 1, it is multiplied x2 minus x1, and due to this minus sign, its symbol is changed, minus x2 plus x. And you can see x2 is simply cancelled out. And what we have got here, we have remained with, this is cancelled out, we have remained with x minus x1. And the denominator of both the equations is same. So simply just I have multiplied by x2 minus x1. This x2 minus x1 on both the sides. Okay. And obviously we have assumed here because x1 is greater than x2. So it is no doubt that x2 minus x1 is positive. So that's why we can obviously multiply it by on the both sides. So now we have got this equation and marked it as number 1 equation. Now we will work on this equation. So I have written separately this equation number 1. What we have to do, actually you have 3 numbers, x2 minus x1, x2 minus x, x minus x1. So I will divide the inequality both sides by x2 minus x, x minus x1. Firstly, we will take care because we have to divide in the inequality that every term should be positive. Now you have to follow this relation and check x2 minus x. x2 is greater than x, so obviously this is positive. X minus x1, and x is greater than x1, so this is also positive. So positive into positive, total number is positive. So obviously we can divide the both sides of the inequality by this number, and the inequality will not change. So we have, I am talking about, we have 3, I was talking about, we have 3 pairs, we have 3 terms, x2 minus x1, x2 minus x, x minus x1. And obviously all of these 3 terms are positive. I have already told you about this. This is positive, and in the previous slide we have discussed this is also positive. So we will multiply, we will divide one by one by taking any 2 of them. So firstly, I am taking these 2, x2 minus x and x minus x1. So to make the inequality, we have to divide by all the possible pairs of these terms. So firstly, I have chosen these 2 terms, x2 minus x, that means these 2, x minus x1 and x2 minus x. So whenever I will divide it, so here you can see this term will be cancelled out. When we divide it by this, its denominator will remain x minus x1. And similarly, in the case of this number, when we divide by this, x2 minus x and x minus x1, x minus x1 will be cancelled out. Its denominator will become x2 minus x1. And here, both these terms are present. So what we have to do in this number, you can see x2 minus x1 are present. So I have subtract and add the x, editing and subtracting the same value x. And now making it x2 minus x separately and considering x minus x1 separately. And when you considering it separately, x2 minus x upon x2 minus x minus x1. What will you are left with? These will be cancelled out. You will be left with 1 by x minus x1. And similarly, when you consider separately x minus x1, this term will be cancelled out, x minus x1. So you will left with 1 by x2 minus x. So this is the trick basically. And you can see with the same denominator, we have this term. So combining these two terms, okay. So its numerator is pi x. So this will become negative when it comes to this side, minus pi x1. Denominator is common. And similarly, these two terms have common denominator. So switching on to this, so phi of x2 is positive, phi of x will be negative. So we will get the equation number 2. And with the similar calculation, you can see, I have just told you earlier that we will divide by taking 2 of the terms out of these 3 terms to establish the Chordal slope lemma. So now in this time, I have taken these 2 terms, x2 minus x. That means previously we have taken these 2 terms to divide. Now I have taken these 2 terms, x2 minus x and x2 minus x1. And in the third step, again we will consider the remaining pair. Okay, so x2 minus x and x2 minus x1. This time because we have divided by this term also. So phi x has the denominator with the remaining value x2 minus x, and phi of x1 will have both the terms in the denominator. But in the phi x2, this term will be cancelled out. You will have this term will be cancelled out. X minus sorry, mistaken. Phi of x1 is written on the back side here. So just I am correcting myself because here phi of x1 is written before and here after. So of the denominator of phi of x1, this term will be cancelled out. You will remain with the x2 minus x. And similarly for phi of x2, this has the numerator x minus x1. So it will got 2 of the terms as the denominator. And similarly, as we have done earlier, x minus x1 was the numerator of phi of x2. Same. So I have here editing and subtracting x2 here. And similarly, as in the previous calculation we have done, just making the pairs with, I have making the pair of x minus x2. Or you can x minus x2 and the pair of x2 minus x1. Okay. So what will be about what will be left with? You can see. So whenever we consider for x minus x2, so this term will be cancelled out. Okay. So you will get, because negative will remain because it has a difference of the negative sign. So you will get negative of x2 minus x1. So you can see here, this is the negative of x2 minus x1. And similarly, whenever you divide, whenever you consider the numerator as x2 minus x1, this will be cancelled out. You will left with the denominator x2 minus x. And similarly, making the pairs of the terms with the same denominator, like these 2 terms have the same denominator. So switching on to this side and considering these 2 terms as they have the same denominator. So you will have phi of x1 minus phi of x2. And what I have done here, because there is a difference of the negative sign, so multiplying by negative on both sides, obviously the sign will be reversed, or this term will come to this side if you reverse the sign, and this term will come to this side. So phi of x2 minus phi of x1 is less than phi of x2 minus phi x. So we have this third equation, this one. So, and finally, the third pair of these 2 terms, which 2 terms have been considered, x minus x1 and x2 minus x1. So dividing by these 2 terms, and similarly, same steps have been performed as I have told you earlier. So you can do it on your own, and you can see you will get these terms, and you can establish this inequality. And I have mentioned this inequality as number 4. Now, combining the third and fourth inequality, you will get the desired result of the lemma. You can see. The third equation, this one. Okay, this equation, uh, pi of x2 minus pi of x1. So combining the third and fourth equation, the third equation which I have shown you in the previous slide, this one, and you can see after combining these two equations, we get the desired result. Just simply clubbing these two equations, you can see this value and just continuing with this figure because this is the same term. So continuing with this, we will get the inequality. So this is the Chordal slope lemma which we require to establish. Now I will show you the geometrical meaning of this lemma also. So if phi is a convex function in AB and you have 3 points x1, x2 and x lying between x1, x2, and if I represent the point with abscissa x1 as p1, point with abscissa x as p, and point with abscissa as x2 as p2, represents the 3 points on the curve of phi. Then what is the meaning of that lemma? You can see the slope of p1p, because you can see firstly we have considered the points for the slope of p1p. You can see like this, phi of x minus phi of x1 upon x minus x. As I have told you earlier that this term was the slope of the points joining x and x1. So you can see this is your point x, this is the point with abscissa x, and this is your point with abscissa x1. So it's a slope. You can see it has a negative slope. P1 has a negative slope because it is moving downwards. So it is a negative slope. And you can see it is less than the slope of P1, P2. So this is the slope of P1, P2, and this is a positive slope increasing. And it is further less than slope of P2. So this is again a positive slope, but it has more slope. You can simply see with the diagram also. It is the slope, and this is more slope in P2. So this is basically the result of the Chordal slope lemma. Or obviously, if your phi is a convex function, because it is a convex function, it will happen always. Because in the case of convex, it is always true. So this is the basically Chordal slope lemma.